Start with the session. So welcome everybody to the session. So this session is basically on PyCaret. So it's called Automating ML with PyCaret, right? So here we will understand what is PyCaret and what this library does, right? Okay. So all your questions and queries, we will like look at in intervals, right? So once we start and once we go through the PPT, and then we will come to your questions also, right? Okay. So this session is about PyCaret, and we will understand what this package is and how it's going to be helpful for us in creating machine learning models. So let's focus on that. And I would just like to add here that this session is basically for 1 hour, and here like first 25 minutes would be I'll be covering the PPT, and after that we will get into the code part of the case study. And yeah, so like we'll also have a Q&A session towards the end of the session, right? Yeah, it will be hands-on. Yes, Jay. Kunnan. Yeah. Yeah. So right now we are not able to share the link with you, but however we'll upload the notebook to the LMS, right? There you can access the notebook. So basically we'll be running the code on Google Colab. Yeah. Yeah. PPT will also be shared with you. Absolutely. Right. So as I said, like we will have like basically first 25 minutes and 25 to 30 minutes I'll cover the PPT, and then we will go to the code, right? And please keep your questions to like towards the end of the session. So there I'm going to address all the questions together, right? If at all, if you don't understand something in the PPT or the code, you can just like raise a query or the question here, right? So are we guys clear with these instructions? Okay, great. All right. All right, guys, let's get started with the session. And the first thing is like I want to tell you what PyCaret is. So PyCaret is basically a machine learning library which is built in Python, and it's essentially going to reduce the life cycle of your machine learning pipeline, right? So there are various things in your ML pipeline, right? And you actually write a lot of code for your pipeline, and you actually like experiment with a lot of models, right? So everything that you do in Python, you can do here in PyCaret as well, right? But there is an automation part to it when you use PyCaret. So you can actually automate your machine learning pipeline or the lifecycle by writing very low code. And in this, we'll okay, my introduction. Okay, so I'll start with my introduction also. Mm, So my name is Varun Rao. I work as a data science researcher at Insaid, right? So you guys like would be putting a lot of queries and emails to us, right? So we resolve all those queries and we prepare all your material case studies. So whatever you guys go through on the weekend classes, right? So those materials are prepared by us. So we are a team of researchers, and yeah, we actually try to ease up all your process, right? So learning process, or if you face any queries in the code or any kind of technical issues you face, so we try to address those, right? I hope Srinidhi, my introduction is clear now, right? So I've been taking the sessions like since like last two sessions I've taken on like rapids and dask as well. So I think you didn't attend those. Okay, no issues. So it's good to give the introduction again. No issues. Okay, all right. Let's get to the agenda of the PPT. So today we will see why PyCaret, why are we going to use PyCaret? Okay, and what are the features of PyCaret? So there are some distinct features that are pretty much like amazing. Basically, they are amazing, and we would definitely want to explore those, right? And you might have a question, and a lot of people ask me like in the past also like, so what do you think, is PyCaret a replacement for Python programming or creating a machine learning model in Python, like learning with Python language, sklearn, and all these things? So we'll address that question as well today. And we need to understand like who can actually start with PyCaret, right? So it's not that everybody can pick up PyCaret and they can just do things. No, that's not the case. So we'll also address that issue, like what is PyCaret and who essentially can use PyCaret, and what are the advantages of PyCaret, like how it is beneficial in various aspects, right? In terms of productivity, in terms of use, in terms of business, solving business problems, right? And also we'll also look at the disadvantages, because as I said, right, so it's not the thing that everybody can just pick up and use. So there are some uh, disadvantages to PyCaret, right? And finally, we will go into the demo case study, and there we will show you some models, basically a regression model and a classification model using PyCaret, right? That is the agenda for today. So let's go and first see what is PyCaret and why it is useful, right? As I said, PyCaret is basically a machine learning library, which is helping you to actually reducing the code lines that you write in creating a machine learning model, right? So that is one of the best features we have, and it's basically a powerful solution, as I said. But however, there are some restrictions or some limitations to it, right? We need to understand that as well. So we will explore this thing. So when I say PyCaret, so essentially I mean that uh, PyCaret, right? So let's take a coordinate system, okay? And now I want you to ask a few questions here, right? So I would just like to know what is the life cycle. I see a VINC. Is it clear now? Yeah, Himani, we will come to that, the low code part. Yeah, that's what I'm trying to explain here, right? So I hope you guys can hear me, right? My voice is clear. Okay, okay, great. We lost you for a few minutes. Oh, few minutes. Okay, okay. All right. So I was considering a scenario wherein we are going to understand what is the life cycle of a machine learning project. Okay. So when I say life cycle, I want you to just answer me in terms of what are the steps that we go through when we create a machine learning model or something, right? So what would be the first step that I would need to take here, according to you? Data cleaning, data gathering. No, before that, what do you think? Data gathering is one of the steps, right? Yeah, but like you have to have a setup as well, right? Tools and a setup that you need to run your machine learning model, right? Yeah. Okay. So I was talking about a coordinate system wherein I'm going to consider my steps. Okay, let me just draw it in a, right. So the first step that I'm going to look at is my experimental setup, the tools I need, and if I need to do some data collection, I'm going to take up that as well. So I'm going to put it as experimental setup. So what would be the next step according to you? Let's say you gathered your data, everything, tools, everything in the first experimental setup. So what is the next step that you think we can do here? Defining the problem statement, EDA. Yeah, EDA is something that we need to do because we need to understand the data, right? So our second step would be EDA. And the third step is what? Missing value statement. Yes. So what is it called in general, Chirag? So there are other things also that we do apart from pre-processing. Yes, Rahul, you're right. So we will do some pre-processing. So I'll put it as PP, right? And after that, what do we do? Pandas profiling will be coming in ADA, right, Omkar? So we will be covering pandas profiling in ADA itself. Feature engineering, yeah, we can do it in pre-processing step. Yes. So we define the model. Yes, Raj. Right. That's the answer that we are looking here. So it's not only that we define only one model. We actually try out many models depending on the data set that we have. Right. So depending on the business scenario or like the problem statement that we need to solve. So we are actually considering lot of things, lot of models, like whether it's a classification task, whether it's a regression task, whether it's like an unsupervised task, clustering, right? So if you need to do anomaly detection, right? So there are a lot of things that we take into consideration. Based on that, I'm going to take a step where we are going to build multiple models. So I'm going to put it as multiple model building. So it's called MMB. Okay. All right. So next step, please. So can you guys tell me like what is the next step after this? Uh, Yes, Raj, you're absolutely right. It's hyperparameter tuning. Yes. So that's called hyperparameter tuning, HPT. Okay. After this, what do you think? Uh, Accuracy loss. Okay, this is called model evaluation, right? So we do model evaluation. So ME is model evaluation, right? Then after evaluating, if we need to do some model plotting or something, so we do the plots and then try to explain to our stakeholders, right? Or then we also go for model deployment steps and stuff, right? But for the time being, I'm only considering these parts, right? So let's take our first step is experimental setup, then we do EDA, and then we take up like pre-processing steps, and then we do the model building. In case if we need to create multiple models, we do the multiple model building, and then we do the hyperparameter tuning. Then we evaluate the model, and based on that, the kind of reports, analytics, insights, actionable insights, or plots, whatever is necessary, we create those things, right? So this is my x-axis, and here I'm going to consider two things. Uh, so essentially, as a data scientist, what I'm going to do here is to visualize our process, right? And to do that, I'm going to take a square notation for my PyCaret. So our PC is my PyCaret, and a circle for sklearn. So I'll put it as skl. Okay. So this is the legend I'm going to take, right? And can anyone tell me what would be there on y-axis? You guys have done EDA, you guys have done visualization, and I think you are pretty much expert in all these stuffs, right? So if I'm trying to understand my steps of machine learning life cycle, so what would come on x-axis based on the context that we are in right now? Time or code of line? Yeah, I can see someone answered number of code lines. Yeah, Sukrut. Yeah, great, great. So let essentially this 0, this is origin. Let's put some values. Okay. I'm going to take the step size of, let's say 20, 40 lines of code, 60 lines of code. Okay. 80, 100, and 120, 140, 160. I'm going higher and higher because you will understand that these are the lines of codes that we write in sklearn. Do you agree with me or not? It might take 200, it might take more than 200, 220, 240. Okay, so that's the limit of our screen, my screen, right? Can you please change the color? Sure, sure, sure. Okay, let's take, is red fine with you? Nazia, is this visible? Okay, great. So yeah, I hope this part is clear, right? Till this part. Oh, okay. I'm going to change the colors. Okay, let's do it in this way only. So this is the number of lines of code we have on our y-axis. Okay. Now the experimental setup, right? So I'm considering a lot of things in here. Let's take our tools. Let's take Python environment, Jupyter notebook. Let's take data. If you want to collect it, you can collect it. If you have it ready-made with you, you have a CSV file, Excel file, you can do that. So to import everything, to load, to start, to import your packages, everything. So the code lines that you write in sklearn, just give me an approximation. How many lines of code you write just to import your libraries and then import the data set and everything. Please use whiteboard. Okay. Jigna, for the time being, let's continue like this because again I have to draw everything in the whiteboard, right? It will take some time, right? I guess it's coming up clear, right? Okay. 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 So let's take, we write 10 to 15 lines of code to do everything in this scikit-learn, right? So I'm going to take this as between like 0 to 20, and for PyCaret, I'll only take somewhere close to between 1 to 5, right? So this is scikit-learn and this is PyCaret. So square is PyCaret and circle is scikit-learn. So this is the notation, right? And if I want to move to from like the experimental setup and everything then to EDA, so the number of code lines in sklearn will definitely increase. We do the pandas profiling, we do pre-processing, we do if we need to analyze some variables of the data set, we do that, right? And then we do also post-processing, right? So everything, considering everything, pandas profiling report, everything, we actually write some code lines, and then eventually, so the if I talk about these code lines, it's going to pretty much increase nearly 40 or something, right? So this is the point where we have these code lines, right? And now, if I talk about PyCaret, I'm just going to add one more line of code. That's it. Only one more line of code. That's it. Nothing more. Okay. So this is my PyCaret. Okay. Again, for pre-processing, you will do if you want to do feature engineering, if you want to remove outliers, missing values, street null values, everything, right? Again, you're going to add a lot of lines of code and write it. This is scikit-learn. But for PyCaret, I'm going to just maybe add 1 or 2 lines of code. That's it. So essentially, whoever, I don't remember the name, but whoever asked me what is the meaning of low code here, so this is what I'm saying. The number of lines of code you write in PyCaret, you can't imagine, like it's like maybe below 50. You won't go to more than 50. The max is 50, basically, right? That is what we are talking about here, the low code, right? It's pretty much easy to use, and if you go for further modeling, then you increase your code lines. So this is a drastic change, and the increase, if you see the increase in the code lines in sklearn, so you'll be amazed, right? But if you look at PyCaret, the curve goes like this, just maybe adding one or 2 lines of code more than the previous step we were doing, right? So that is the change of curve we see, and that is the change in code lines that we do in scikit-learn and PyCaret. So I hope this diagram makes it pretty much clear for you guys to understand what is low code in PyCaret, right? And how about time? Time is pretty much same. There's no difference in time. So both are like pretty much same. Yeah. We'll talk about which algos it supports, definitely, Ramesh. So there are like 6 kind of modules that we have in PyCaret. So we will discuss those, right? Definitely. Okay. I hope you guys are clear on this part, right? When I say like low code, this thing. So this is what I was showing you here, right? And indeed, it is a powerful solution. MP here means, so okay, plotting. So it's like you plot, let's say you want to plot a precision recall curve, right? Or AUC curve and all these things. Again, for that also you need to write code, right? So yeah, so the code lines will increase basically for writing all these things, but you don't have to put a lot of effort in PyCaret, because in PyCaret you will get all the plots together in one frame, right? You can see all the plots together. It's just like you need to click on a tab and you will see the plot. I'll show you the code. Yeah, both the same, Anil. Like you can say anything, less code, low code, everything, no issues. It's up to you, right? Can we run in GPU also? Uh, no, not necessary, right? So if you want to, like, you're working in the same way as you do in Python environment, it's just like you can use Google Colab or something. Don't know it for a GPU. Just do the normal thing, right? It varies. It depends, like when you actually take a big data sets, right? And so there is an NLP module in it. There is an anomaly detection module in it, right? If you are doing that, if there's a requirement, definitely you can go for it, Raj, right? No issues in that. Okay, guys, are we guys clear till this part? I hope we are. So let's move forward to the next part, right? Yeah. So I was saying that you actually use low code, right? And it's basically uh, essentially, like, for me, it's like a tool, right? So Python is basically a tool that we use to do data science, machine learning, and deep learning and stuff, right? In the same way, PyCaret is also like a tool for me, but the productivity, the kind of productivity that we see, right? So this is the productivity that we are talking about, right? So if you see, right, you don't have to invest much of time in writing the code lines, right? So ultimately your productivity increases. So there's an increase in your productivity, and it's basically a very productive tool, we can say, right? And it's pretty much easy to use. You just have to understand. If you have an understanding of machine learning, you can definitely do it, right? Yeah. And moreover, if I'm looking at some business study solutions, let's say we have small organizations, like we don't focus on Facebook, Microsoft, Google, or Amazon or something, right? And there are various other companies, right, which are like medium enterprises and medium organizations, right, who don't have much of infrastructure, or who don't have much of financial support to get that infrastructure that these companies have, right? Because they have their own databases and everything, right? And so for those kind of organizations, if they are hiring data scientists, right, definitely this kind of tools will help them to create some business study solutions for them, right? So that is what we are talking about when we are using PyCaret, right? All right, guys. So I'm going to clear my screen here, and we will like now move on to our next. Yeah, PyCaret can be used in R as well. So I'll tell you one more thing here. Okay. So if I talk about Caret, so Caret is a package in R. So the concept, so the founder, basically the person who created PyCaret, his name is Moiz Ali. Okay. And he took this idea of PyCaret from essentially the R package. It's called Caret, right? And from there he derived this PyCaret for Python. So Py comes for Python, and Caret comes from the R package, Caret. Okay, so that is the idea. That okay. I hope, Chirag, we are clear in this, right? And that answers your question. Okay, cool. All right, let's move on to our next slide. So we'll understand what are the features we have in PyCaret. Okay, so there are six features essentially. So I'm going to discuss those. So if you want to do data preparation, you can do that in PyCaret also. If you want to remove outliers, null values, or if you want to pre-process something, do some feature engineering. Yeah, so you won't find all those features that are there in Python, definitely, but you will find whatever are relevant and useful, right? So you can definitely do data preparation in Python, sorry, in PyCaret. And you can do the model training. So all the algorithms, all the linear regression, logistic regression, supervised, unsupervised, clustering, everything, all kind of models you can create in PyCaret, right? And essentially we do hyperparameter tuning in order to bring out the best models, right? So that thing also you can do in PyCaret as well. We analyze and we interpret our models. Definitely all the visualization, charting, plotting, everything you can do in this also. the model selection. If you want to select some models, okay, what you do in Python? In Python, you basically create a model. Let's say your first model is a regression model. Okay, you create this model and you just then evaluate it, and then you understand, okay, this is not working good. Okay, then you go for some DT regressor or random forest regressor or something. Okay, then you try to evaluate this, and then based on this you get a, okay, out of these three you feel that, okay, this is good, doing pretty much well on my data, you'll select this, right? So this is the process that you do in Python. But in PyCaret, you will you will pre-process your data, you will then create the model. Okay, everything would be done only once. So there's one step for this, one step for this, second step for this, and then you just run the model, train your model, and you will get a summary of all the models that are present in PyCaret, right? You will get a summary of all those things by just they will be just defined by some code, right? If it's like linear regression, it would be LR, and essentially you will get the full name of it, right? But definitely, but there's a code for the models that you need to select. Okay, so you have linear regression, then you have DT regressor or something, and then you can select this one, and based on this you will have all the metrics defined. So let's say MSE, MAE, all these things. So all the models that you want to evaluate, you can evaluate here, and then out of it you can select one. So whichever is the best performing, it is going to highlight everything for you. So whichever is the best model, it comes on top. The number one model would be something which performs well on all the aspects, right? So that is what the model selection you can do here. There is also part of experiment logging, because as I said, right, we can do the experimentation, because machine learning is kind of experimentation. You create models, you test models, and then finally you bring up one solution, right? So experiment logging is something, but we will not consider that. We are not going to discuss this thing in our session now. Okay, we will consider all these 5 parts. We will understand this and we will go through this, right? Are you guys clear here? I mean, instead of we experiment on different hyperparameters and algo, we get all result from Padarth at one shot. What does Padarth mean, Anil? Result from, I'm sorry, Anil. Which Pike? Okay. Oh my god. Okay. PyCaret. It's PyCaret. Sorry. Okay. Oh no, no issues, no issues. Okay. Even I didn't get that. Like my bad. So you mean automatically it will run all the models? Yes, absolutely, Arjeet. So it will run all the models and you will get everything in detail, right? You can actually, you have the liberty to select your own. In fact, you don't have to select your own. It is going to automatically give you the first best trained model for you with all the metrics, right? I'll show you everything, right? Yes, yes, yes. Will it show the, yeah, it will show the results for all models, Jigna. Definitely. You'll see, you'll see. Yes. Okay, okay, great. So are you guys clear with this part, that what are the kind of features that we have? All the features that we have in Python, the scikit-learn, everything, we have it here. You just have to just understand it and then uh, go with it, right? So post EDA, we can jump to PyCaret. Yes, you can do that, definitely. This is actually a wonderful a wonderful question that you asked, Vismay, because I was about to tell you, like, why PyCaret is not so good thing or a good tool to go with, right? Essentially. So EDA is a very important thing that you have to pay very much closer attention on variables, right? You have to understand variables, you have to treat them, you have to engineer them, right? And a lot of things you need to, if you are running a regression model, you may need to make sure that your target variable is normally distributed or not, right? You need to check that, everything. So yeah, there are limitations to PyCaret, so we will discuss that, right? Yes, Anil, it does support production code. So there are libraries which support this, and there's ML Flow. You can do that. You can deploy the code in AWS as well, right? So we are not going to cover those things definitely, but yeah, these provisions are there. You can just explore. You can just go and explore. Once you get an idea of what you are going to understand from PyCaret, what you're going to actually leverage from PyCaret, definitely you can just explore and you can do things, definitely, because there are a lot of tools which we can integrate into. For example, Power BI is one. So essentially Power BI, PyCaret, uh, we can integrate PyCaret in Power BI and do on the dashboarding and stuff, right? And the next thing is uh, okay, the next thing is you can do, if you want to create a machine learning model and take it to your SQL database or something, you can do that, right? You can use it with Python, right? Lot of things, AWS. Okay, Nazia, you're saying, would you encourage us to use this for our ML projects, or is it better to use the method taught in the classes? Yes, I'll address that question, definitely. The next slide is basically on that. Okay, that's a good question, Nazia, so I'll address that, definitely. We can say it is Keras for ML, as it is high level tool and wrapper around SQL. Yeah, you can say that, but like, yeah, there are differences. Like Keras is like, I think Keras is way too far. It's pretty advanced, right? PyCaret is basically essentially in its development stage, and there are a lot of other features to come, essentially, right? So there's a difference between both Keras and PyCaret. Yeah. It's just a tool to make your lives a bit easy. Yes. Okay. All right, let's go forward. So this question, I want all of you guys to answer. What is your opinion? Like, yes or no? Is PyCaret a replacement for what we do? Raj says no. Ahmed Duggal, no, 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 no. Oh, I'm actually pretty amazed. I was in a notion that people will say yes, it is, and it's going to change everything. Okay, maybe I was wrong. In a way, yes, Vismay, in a way, yes. So there are like some limitations. Obviously, like when you understand which model is performing better, you will definitely take that. But yes, there is some decisions that needs to be taken as a data scientist for you, right? Okay, okay, great. Thanks for your response, guys. So let's go forward. Okay, so now we are going to understand basically a concept of basically two terms. One is citizen data scientist and another is seasoned data scientist, right? PyCaret is something which basically I think, and also a lot of other people think, that it's created for citizen data scientists. And what are citizen data scientists? We'll get to that, right? And there's an article by Gartner. So if I click this, so essentially, Gartner released an article where they say citizen data scientists and why they matter. They have gone through like an in-depth description of what citizen data scientists are and why are they useful and why are they important and how they are different from the normal seasoned data scientists that we do. Right. So there's a link to it in our PPT as well. So you can just guys can go through this link after the session. Right. You can just download it. Oh, sorry, you can open it in a browser and just go through it, right? Yes. Just a second, guys. I think there is some issue with my PPT. Give me a second. Uh, yeah. Yes. Yeah. Okay. Was not able to avail the present option here. Okay. Um, yeah. Can you see my screen now? Yes. Okay. Great. All right. Sorry for that. Okay, so I was talking about citizen data scientists and seasoned data scientists, right? So what is the difference here? So let's consider difference, and I think red is visible here, right? So in my opinion, and basically I have gone through the article as well, and what I think is citizen data scientists are the people who are like complementary to the actual data scientists or the seasoned data scientists. Complementary in the sense like they don't delve into the concept of like understanding statistics or creating uh, algorithms, right? Writing algorithms such as the whatever algorithms we have, linear regression, logistic regression, everything, right? They are just here to uh, go through some like sophisticated models, create some predictive sophisticated models, like, and then basically resolve the business problems, right? So they don't get into the depth of what mathematics is behind it, and they don't try to recreate an algorithm or something, right? It's just that whatever tools they have in hand, let's say PyCaret, right, or maybe some other tools, they can take this up and they can just master those tools, and based on that they can just come out with solutions to the business problems that they are dealing with, right? So see, citizen data scientists are something that I feel like they just try to come up with solution, okay, using tools. They don't get into the statistics and all these things, right? And seasoned data scientists, SDS, so seasoned data scientists are someone who are pretty much experienced, who come from experienced background, such as like they might have masters in computer science, right? And they might have done PhD or something. And essentially, you will find these guys in all companies such as let's say Google, Facebook, Amazon, right? Microsoft. All these people have these kind of profiles: computer science backgrounds, statistics, or mathematics, physics, operational research, and all these things. They have masters in it, they have PhDs in it, everything, right? So seasoned data scientists are someone who try to actually create uh, the algorithms, and they understand the mathematics and everything, right? But see, citizen data scientists are someone who actually use tools such as they can use scikit-learn, okay, and they can use PyCaret, and based on these tools they can come up with models, create models. But see, one thing is common in here, like they have to, like, they learn data science pretty well, they learn machine learning, they know machine learning, they have to do that, right? in Without learning these things you can't do anything. PyCaret is of no use if you don't do this thing, right? So essentially, whatever course you're going through, whatever things you're learning in Python, data science, visualization, machine learning, AI, all these things, you have to go through this. You have to go through this rigorous training, definitely. And after that, it's up to you. If you think that you are not so of a coder, so one more difference I can say here is that all the non-coders. So I'm going to say NC for non-coders. All the non-computer science graduates, right? Who doesn't have masters, PhD, something. Okay, all non-coders, all non-computer science graduates can become a citizen data scientist. And I think so. This is a term that's going to be a buzzword in future. Let's say let's enter into 2021, right? Okay, and we will start getting roles such as citizen data scientist in various companies, right? So that's what I think that will happen. So all the non-coders can leverage PyCaret and create solutions for your business problems. And seasoned data scientists, one more thing, all the seasoned data scientists are coming with a lot of experience, and they are pretty much expensive to hire, right? So there is also a cost factor here you need to consider. So they take packages just like 25 LPA, 30 LPA, 35 LPA, depends based on the experience. Let's say if they have experience of like 5 to 10 years as a data scientist or as a machine learning engineer, so you can just imagine their packages is like it's way too high, right? So they are pretty much experienced, right, in their space, and they're like masters, and they are pretty much expensive in terms of hiring them, right? Okay, Vimal, yeah, we will definitely see that, right? So I hope this concept of CDS and SDS is clear, right? Citizen data scientist and SDS, right? That's why it's not a replacement, definitely. I'll basically agree to your answers that you gave, right? and they are basically the data scientists are like the power users who can actually simply use simple models or maybe basically moderately sophisticated models and come up with solutions to business problems. Whereas the other set of people, like the seasoned data scientists, can actually uh, show their expertise and work on various in-depth problems that we can see, right? Okay. I'm a non-coder. Sometimes it's very difficult for me to understand the coding part. Yeah, I understand. I understand, Shakif, definitely. So we are going to address that issue, and I think you can pretty much leverage the power of PyCaret, right? Okay. So guys, are we clear till this part? Can we move ahead? Okay. Okay. Great. Great. So the next question is like it's not a question. Basically, it's a thing to address. Basically, so who all can utilize PyCaret, right? So PyCaret is basically ideal for whom? So that is one of the things that people keep asking, right? So let's go into this details, right? So as I said, like experienced data scientists can also use this package or do use this library PyCaret in order to increase their productivity, right? So productivity is something that we talked about in the first slide, right? Because if you think that you are like losing out a lot of time on writing code and creating models, then probably you can use it as a replacement. You can use PyCaret here and basically increase your productivity. If it's going to resolve your problem, it's going to resolve your business problem, right? And give a solution for your problem. If it's not, then probably you need to go back to your native mode and do stuff there, right? So essentially, even if I'm saying that seasoned data scientist doesn't require it, if they want to increase their productivity, they can definitely do it. No issues in that. Okay. Yeah. Now is the part like citizen data scientists who prefer low code machine learning. So people like Shakif, who actually come up with their problem and say upfront that, okay, I'm pretty much finding difficulty in understanding code and coding for machine learning algorithms, can definitely leverage the power of PyCaret, right? Shakif, you can definitely do that, right? However, if it's resolving your business problem, if it's going to help your model and everything, you need to see that as well, right? Students of data science who are like just okay, when I say students of data science, it's not just like they just get started with PyCaret. No, that's not the thing. As I said, right, you need to go with the fundamentals. You need to understand what is data science. You need to understand what is machine learning, right? Then if you want to go into AI stuff, right, you need to understand that as well. So if you cover these two aspects, definitely you can start with PyCaret. Okay, so all the students who are just want to start with PyCaret, they have to have the understanding of what is data science, visualization, EDA, and machine learning models, algorithms, and all these things, right? And lastly, the data science professionals and the consultants. So one benefit I see here is basically, as I said, that founder Moiz Ali, right? So Moiz Ali was he's a data analytics leader. So he works for some corporation in Canada. So he's a data analytics leader, and basically by profession he's a chartered accountant. That's what I know about him. Like I read the background, right? So he's chartered accountant, and he's working for some organization as a data analytics leader, where he tries to like bring up models and do analytics and stuff and resolve problems, right? The business problems. So basically, if you're a consultant working if you're working as a data science consultant, yeah, if you're working as a consultant for some firm and you think that you don't know Python programming as such and you want to understand modeling and analytics and stuff, then probably PyCaret is something that you can do. So you can definitely use PyCaret here, right? If you are a data science consultant, or professionals basically. So what they try to do is like they try to build the proof of concept for the projects they are working on. So consultants basically are assigned to multiple projects, right? They have different projects coming up for them. So they need to create the POCs for them, right? So there you can use this PyCaret tool because it's pretty much productive that it's going to take less of your time in creating a proof of concept, basically to analyze your model, and then if you're okay with it, then you can go for the production, or you can just present it to your stakeholder, right? So that is one thing. Okay. Yeah, so this is what we have in the slide. So PyCaret is something, this is ideal for all this kind of professionals that we are talking about, right? And especially like people like Shakib, Shank, they can definitely leverage this to the best, right? I hope, Shakib, I answered your query, right? Okay, let's move forward. Are we guys clear with this part? Okay, okay, great. Let me clear the screen. So advantages of PyCaret, we will see. So as I said, it's low code. You don't have to use any. You don't have to write like much code lines here. You can just write simple code lines, and you can just start with the PyCaret library, right? Second is like it comes as a wrapper for all your Python libraries. Not all, but specifically if I talk about sklearn, so it's going to cover everything what you have in sklearn. If you want to talk about regressors or uh, classifiers or clustering, right? NLP, a little bit of NLP, anomaly detection, right? And one more thing, association rule mining. So that is one thing, right? So there are 6 modules essentially. So first is regressors, second is classifiers, third is clustering, so I like cluster, fourth is NLP. So let's take anomaly detection. So I'll say anomaly, okay. And fifth is NLP module, and the last one is association rule mining. You can do this as well here, right? Rule mining. Okay, so there are 6 modules essentially which PyCaret covers, and I think there was one question in the beginning of the session that what all algorithms and modules that does PyCaret cover, right? So this is the answer for that, right? So you can cover all these modules here, right? So you can see that it's like just one line of code to perform data processing and feature engineering, as I said, right? So it's like just write one line of code and everything will be taken care in PyCaret. Okay, you can compare several machine learning models and tune it. Basically, if you want to do some hyperparameter tuning and everything, you can tune it and you can just simply go ahead with your final model, right? All right, guys. So one last thing that we are left with is basically the disadvantages. Okay, and I think it's pretty much important for you to understand these things as well, right? As I said in the beginning also, you will not be able to utilize or leverage PyCaret if you don't know machine learning, right? It would be like a black box for you. You don't understand what is going on there. That is one thing. And even if you know something, if you know ML algorithms, you know linear regression, you know logistic regression. So I see there are folks in the class who have completed ML1, right? And it will be more popular in non-coders, but around code running will take same time, right? Yeah. Yes. Code running will take same time. No issues in that. Yes. Okay. So even if you we don't have facility to experiment. So what kind of facility are you talking about, Anil? You can do experimentation, like if you so experimentation is also like it's like you can do experimentation in less time. If you want to see multiple models, you can just see it in one line of code. Yeah, it works well. It's not there's no issue in that. So essentially, you don't have deep learning and all that kind of modules here, right? So so if you want to analyze image data set or something, so that thing is not possible. Like however, if you want to do tasks such as NLP tasks such as topic modeling and stuff, yeah, you can do that. There you need to just have a text data, right? So yeah. Okay, so if you know linear regression and if you know logistic or all the basic algorithms we teach in ML1, ML Foundation, right? After that also you won't be able to understand what's going behind, right? So you will not have a clear idea or intuition why is it picking up the this model. So it's going to so there are multiple models in it. If you talk about classifiers, if you talk about regressors, there are multiple models, right? So yeah, so you need to you won't be able to understand that. That is one drawback. That is one disadvantage we have. So it's just that you'll get the results, and based on that you need to take decision with which model you're going to take up with. So you will get XGB as your best model, right? You need to go with it. If you want to do hyperparameter tuning, and if you want to remove this model and then take up another model, right, you can do that as well. So that functionality we can talk about, right? We will see in the code as well. So that is one thing. So it's like a pretty much black box for when you see it from outside, right? You won't be able to understand what's going inside, right? And second thing is it's going to make the learning process superficial, as I said, right? I would highly recommend that if you go through ML foundation training, if a person is going through ML foundation training, okay, he can pretty much understand the things, right? If he or she is going to go through ML intermediate, right, then definitely it's a like a yes from my side. They can pretty much carry on with PyCaret, okay. And if you are familiar and covered ML advanced, okay, then it's a big yes from my side. You can just go and jump into PyCaret and explore it to the fullest, because then you will be having a fair amount of idea with XGBoost, boosting, bagging, all these techniques, right? Stacking and sampling and all these things. All the high level algorithms, advanced algorithms that we teach in ML Advanced, you will be having an idea of those things, and definitely you can understand all the models that are displayed in your evaluation, right? So then you would be able to select the best model for yourself, right? Based on the parameters and all the evaluation metrics that you come up with, right? Okay. So yeah, PyCaret will take time to run on Jupyter notebook. No. It's going to take the same time. No, it's just that simple installation of PyCaret, like the way you install other packages. You just install it, do the pip installation, and then you will be able to run it in the same way that you do in Python, right? Yes. Yeah, definitely. You will get this models, LDA and everything. You will get this models. Yes, definitely. Sure. I'll show you. I'll show you. Not taking much time but for installing PyCaret, you need to create a new environment. Yes, Reena. So, okay, so this is an answer. Okay. Okay, let's jump to the case study. Definitely, we will do that. I'm just going through the questions once because we are just like at the end of the PPT. Okay, Rohit. Yeah. Just few seconds more, then we will get into the action. Right. Okay, great. All right, guys, let's go and look at the case study. Right. Yeah, I hope you guys can see my screen, right? Mm, yes. Okay, great. Okay. Yeah, so this is the case study, and like the table of contents are basically something that we're going to look at, right? So first thing is installation. As I said, it's just simple code. You just go and pip install PyCaret in your lab, or if you want to do it in your simple Python environment, in your simple uh, desktop or laptop or something, your system, you can do that there as well. You need to create an environment, definitely, because there are some dependency installation issues that happens, right? So you can do that. Yes, Sandeep, we will share the notebook, definitely. So you want me to zoom? Okay, is that okay now? Okay, Ankita, is it okay? Like, can you see the screen and code? Okay, great. Yeah, so it's simple pip install. You just need to install it, and you will get everything, right? The installation will happen. So let's go forward. Now what I'm going to do, I'm going to import PyCaret, and I'm going to import our basic packages in Python, NumPy and Pandas also, right? And then I'm going to check my version, because so can you repeat what you said about environment setup? Arijit, so yeah, there's an issue of some dependencies. So if you are creating altogether a different environment for your PyCaret, then probably that will work best for you, right? If you don't, then there would be some installation issues, dependency issues that you might come across, right? You can try it. If something occurs, you can drop an email to academics, and we will definitely resolve your issue, right? No problem in that. You can try, or else you can just go with the collab. Yeah, you can go with the collab also. Yeah, setting up it in local environment. Okay, so now I'm going to check the version, because there are two versions. One is 1.0 and second is 2.0, and 2.0 is the latest version with a lot of advanced features, right? So we'll see those features also. And 1.0 was basically the first launch that happened like few weeks back. I think it happened in June or July something, early July something, right? So that is one thing, and after that, like we also trying to like show you the features which are like basically from 2.0, because these are like the updated versions, right? So again, I'll check it for you guys. It's 2.0. Okay, so now we're going to focus on PyCaret for regression. So the problem statement that we have here is basically like that we need to predict the insurance charges, like the insurance. So essentially, when we buy an insurance, we pay the premium, right? Every year or monthly basis or something. We do the premium. So basically, yeah, the latest version came in July, Arjit. Yeah, right. Okay, so yeah, so we need to predict the insurance amount, the charges that the person is going to pay annually or monthly, right? So that is the problem statement, and the variables we have here is basically the basic things like such as age of the person and sex and the BMI, the number of children's he or she has, whether the person is smoker or not, and region in which they stay, and finally the charges. So this is the target variable we have. Okay, so TV is a target variable for us. But so essentially, what we do in Python, we know that what is the target variable, and based on that we do the analysis, do the EDA, and based on that we do the splitting and everything, and then try to predict it, right? But this is a bit different in PyCaret, so we will see that. Okay. Yeah. So age and everything is clear, right? So this is the code to import data set, right? So this is the link from the GitHub we have pasted, okay? And the same thing, pd.read_csv you need to use, and you're just assigning your this data set to your variable called df_rect. So just run this and your data would be loaded, right? You can see everything. You can do the head and everything, you can do whatever way you want it, right? Okay, so one more thing I can show you here is, right, there are inbuilt data sets in essentially, like when we talk about PyCaret, there are some inbuilt data sets that are already present there. If you want to work with them, you can work with them as well. So for that, you just need to write simple code from PyCaret dot datasets. Yeah, dot datasets. Like you need to import. There's a function called get_data, right? So you need to run this thing, and if you want to list out all the data sets that are present inside PyCaret, you need to run one more command. So that is get_data. Okay, and in this you need to give index. Okay, so let's run this code. So can you see here? So it's a list. It's basically a tabular format of. So this is the data set, the data types we have, multivariate, and all these things, right? Text. Okay, and then we have default task. So this is for like anomaly detection, this is for association rule mining, classification binary, and classification multi-class stuff, right? And target variable also defined. What is the target variable in this? And target variable 2 if you want to go with some kind of other problem statement, right? And what are the total count? We have rows, attributes, missing values, no. If there's a Y, then you will have missing values in it. Okay. So these are the names of the data set. You can just, if you want to just, let's say you want to get the data set as, oh, I'll just add a code line here. Okay. So I'll just pick any data set. Let's say juice, right? If you want to get that juice data set here, what you'll do, you just define a variable such as, like, let's say data. Then you just go get underscore data, and then you just define juice. Okay, so then you will be able to see the data set. Okay, so this is the, like, data set that you have. ID, purchase, week of purchase, store ID. So this is kind of a transactional data, and this is the purchase is the target variable here. If you look at the juice data set, yeah, the purchase is the target variable here, right? You can use these things, right? Okay, Jitender, we'll go video now. Thanks for the session. Okay, Jitender, you can carry on. No issues. Okay. So are you guys clear with the data loading and everything? If you want to load it from the simple Excel file from your system or some GitHub or something, you can do that. If you want to use these datasets which are built in, because we also have built-in datasets in Python as well, right? We know that. There's like cancer classification data and a lot of other things, right? The same way, PyCaret also has brought up some inbuilt datasets. So if you want to access these things, you can just write these code lines and you can do it, right? Yeah. So next is initializing the setup. For doing that, we need to import the module, right? Can you please clarify the URL here? Okay. So this URL is nothing but that the GitHub URL that we usually get in your case studies, right? So it's the same thing. Once we share this data set, this case study with you, you will get, you can access it, no issues. Is it clear, Abhijit? Yeah, get data is functioning here, yes. Okay, money. Need to drop, we'll go through recording, thanks. Okay, Samir, no issues. How to do with new data set? So this is the new data set, right? So we imported it from our, like, basically GitHub. So this is insurance, right? This is not present in this, it's not built in, like it's not inbuilt in PyCaret. So we imported this, right? Avinash, are we clear? Okay. Yeah, Sagar. Yeah, you will find this session in the LMS, definitely. Yeah, morning. You will get, like, in the first half, you will definitely get it. Okay. So that is one thing. And now let's go to import the module that we need to go, like, create a model for. So get it as an inbuilt function. Yeah, it's a PyCaret function. So you will use that to get the data, which are inbuilt data sets in the PyCaret money. Yes. PyCaret regression. So if you want to do a regression model, if you want to create a regression model, then what you do, you write from PyCaret dot regression, you import star. So import star will take up all the modules that you use in this modeling, right? If you want to set up the environment, if you want to create a model, if you want to evaluate the model, everything, right? So if you want to essentially just only take up one simple module. So let's say there is a set of function where you try to actually initialize your PyCaret environment, right? So this setup function is utilized for that. So we will see what is that setup here. So this is a setup function wherein I'm going to define my data, right? And my target variable and the session ID, which is basically nothing but the seed that we define in our Python, right? Can we not write from PyCaret import regression? No, Arijit, it's not that. So the code is bit different here. So you need to write from PyCaret regression import all. So you need to, if you want to import all the modules, you can just put star here, or if you want to just take up some selected modules, just like setup or something, or create model or something, then you can use this. Okay. So I'm going to do the star here. I'm going to input all the modules here. Once I do that, I'm going to initialize my setup. So initializing setup is something where we use the setup function. Setup is a function where it's going to initialize the PyCaret environment wherein we can create the model, right? Session ID is random. Yes, you can randomly allocate anything because it's like it's more sort of used for experimentation, right? So if you want to reproduce the model again and again, right? So that's why session ID. Yeah, I'm telling about session ID, Reena, right? So session ID is something that you started with your model, okay, and let's say you were building a linear regression model, and you creating this model once, okay, and then again you want to reproduce it at maybe at some other time, right? Again, if you want to get the same model, the same number one model, what do? You assign some session ID to it. So let's say 5974 is the session ID for you, okay. You can do that, or maybe you can first just run this code, just omit this part, okay, and you just run this part of code until this point, okay. Then again you will get the session ID. So based on the session ID, you can just select this and then paste it here, okay. And again, when you come back after some time, or maybe like maybe a few days later or something, again based on the session ID, you will get the same model again, right? It's like a setting the seed that we do, right? It's like for the reproducibility of the model again and again, right? Are we clear, Reena? Yeah. Okay, great. So this is the regression setup. So in setup function, we have this, we need to define data. Data is equal to df underscore rec. So if you see here, we have df underscore rec defined here as a data. So we are going to import that data here, not import, we are going to take up that data, and I need to define a target variable. So just imagine we are going to define a target variable right in the front. Like we don't have to just wait for the later part. So here I'm going to put my charges as my target variable. Session ID is something that I leave it to you. For the time being, I'm going to take up my session ID, right? Like this. So I'll run this code. Once I run the setup code, it's going to set up the environment. So can you see here? So it says processing, right? And it's initiating the things. One thing that you need to do. So it's preparing the data for modeling, right? So following data types have been inferred automatically. So it says all the data types in my particular data set are inferred automatically by PyCaret. So if they are correct, we need to press enter to continue, or we need to type in quit to quit. Like otherwise, if you want to redo it again, right? How to know a valid session ID? As I said, right? So you can just select this part of code and then run this part of code like this till here. Okay. So what I'll do is I'll put in here. Okay. Run this part of code. As soon as you run it and you just put an enter here, you will get the session ID again, right? That is one thing. You can get the session ID from there, and then again you can copy paste it here. Just copy from there and paste it here, right? If you want to rerun it again, right? Yes. Oh, yeah. We will talk about it, Avinash. Yeah, definitely. Yeah, session ID is optional. You can change it. So Avinash, coming to your question. So as I said that it's going to following the data types have been inferred automatically. If they are correct, press enter, or otherwise we say quit, right? So here my age is numeric. So if I see my data set, so my age is numeric, right? And my sixth variable is categorical. Okay. And then BMI is numeric. So I pretty much know, I have seen it, and I pretty much know that like this is numeric, and then this is categorical, right? This is some text, and this is like again that. So this is the target variable here. So for that, so it's going to take up age, numeric, categorical, numeric, categorical, right? Okay. So now I have 4 categorical variables and 2 numeric, and I'm pretty much okay with it. I know that these are the correct data types that I have. Children should not be numeric or not categorical, right? It should be, because see the value is like 0, 1, 2, 3 something, right? Because it's categorical if you want to put it. So if you have continuous values such as like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and some point values, floating point values, and all these things, then you can say it's numeric. But here only we have, so either the person is having 0 child, or one child, or 2 children, 3 children, something like that, right? So it's pretty much categorical, I think. Amit Duggal, right? And Sukrut as well, Sukrut Shetty. I think that clarifies, right? Okay, so once we do that, we know that this is the thing, these are the variables we have. Now I'm talking about this label. Why is this label? Since it is a numeric kind of a variable, it's showing as label because I have defined it as my target variable. So it's labeling it as a target variable. So that's why we have a label data type here. It's not a data type, it's just a label that it's a target variable, right? Okay, so I'm going to press the enter here. Now, as soon as I press enter, coming to the question of Avinash says that if we don't know if our variables are wrong, then like obviously you can ignore it. So there is a feature called ignore variables. Let me just check here. Yeah. So this is called ignore features. You need to define. Oh, sorry. You need to define ignore features, and you can get, if you want to ignore it, just ignore it, right? I think Avinash, this answers your question, right? Okay, great. So see, one thing PyCaret automatically does is if it finds ID, so it's going to label my variable as ID here. Okay, if it's find date time data type, and then it's going to label my column as date time. Okay, and what info are you referring to? Okay, sorry. Coming to the question that Sandeep asked, so this is the original data, the shape of the data. So we have 1,338 rows and 7 columns. Okay, so this is the session ID that we have. We didn't transform our target variable, that's false. So we didn't transform the target method, that is also none. So this is the shape of a data set. Missing values, there are no missing values, it's false. Okay, numeric features we have 2, categorical features we have 4, ordinal features we don't have anything. And one more best thing is, this is the sample data we have. Okay, total data we have, out of which it's going to transform or train, and it's going to split our train and test automatically. We don't have to write the code lines for train and test it. Isn't that great, right? So you don't have to put the lines of code of train test split and then enter how much you need to take up and how much. 80/20, Sandeep, no. 80/20, the default is I'll show you. The default is train size is 0.7, 70/30, right? Okay, okay. All right. So everything. So you need to just go to the documentation. You can just read out everything, and based on that, you can get all the information that you need, right? So just go through the documentation completely, and you will understand what kind of features you can get out from this particular setup function of PyCaret, right? So you do it, again, the transformation of train and test set is done automatically by PyCaret itself here in the first step itself. So it just, imagine, it's just, this we can't change, right? By default, you can mention. So that is why it is variable, right? So it's a parameter that you can mention, right? Jigna, you can just click on it, you go and put this parameter here, select this train size, pick it up. I'm going to copy it. I'm going to just paste this and put it as 8 if you want 80%. That's it. Simple. Right? Cool. Okay. Let's go forward. Yeah, transformation done. A lot of other things. PCA method. PCA is not applied here. There's no PCA done, right? Everything, outliers, threshold, remove multilinearity, false. Outliers, there were no outliers. Everything is false, right? Now, comparing models. So see, all the kind of data processing or pre-processing that we need to do is done in one single step here. Simple this step. Okay. If you want to remove outliers, if you want to fill the missing values or anything, something, all or everything is done here, right? Train, test, split, everything is done in this step. The setup is ready for your model. Shakif, yes, there's a kind of magic, but we don't actually call it magic because there are some limitations and restrictions as well, as we discussed, right? So we need to consider our business scenario, our business case. Let's assume, right? Really a nightmare. Why is it so, Sunil? Because let's discuss a case scenario wherein you're getting your data set from your stakeholder, but he doesn't define the business problem for you, right? There's no problem statement for it, and you don't know what is the categorical variable, sorry, what is the target variable, and which one should I pick up and how do I model it, right? There are some scenarios like this as well, because uh, non technical people doesn't understand data science, machine learning as much, right? So they just think that if we give data to them, they can just build up the model and come with the solution, something. So we have scenarios such as like that. So we need to understand uh, how we need to pursue the models, right? Whether we need to understand the target variable, do the EDA completely in Python, and then come to PyCaret for modeling part or something. Like we can do the pre-processing, we can understand the target variable, everything, and then come back to it, right? So that's what I was talking about. Okay, let's go forward. You do it, and then after that you do this, come to this compare models. So compare models is something that I was talking about, right? So here you have all your models listed down. You have 0 to 21 models. So I think you are familiar with, if people are familiar with these are like advanced models. Random forest is something everybody knows, right? And catboast is some advanced model, right? Adaboast is some advanced model. Decision tree is something everybody knows, right? Lasso regression, these are like the regression techniques that we have. So this is a linear regression, right? So there are some models which are like some pretty much advanced models also that you don't have to go through if you don't know about it, right? But whatever is requirement for your business problem or problem statement, you can just pick it up. So for this model, I'm going to run this particular compare models function. Okay, so if I talk about compare models function, what all parameters I have. Okay, so there's a thing called blacklist. Okay, so there's a thing called blacklist, there's a thing called whitelist, there's a thing called fold, round, sort is something that you can sort based on particular metric, and then like verbose true and all these things, these are like default things. If you want, you can just explore this here, you can read the documentation and you'll get the idea. I'll talk about specifically the blacklist thing and the whitelist thing and the folds also, right? So blacklist is something, if you don't require this model, if you don't require this model, if you don't require this model, and if you require only random forest, if you require decision tree, if you require linear regression, only these models, right? Okay, so you can blacklist all these models, right? But then if you want to blacklist all these models, you have to write the names of all these models, right? There's a basically there's a code to these models. So for linear regression, it's called LR. Okay, for XG gradient boosting, it's called XGB, right? So there are this code. For random forest, it's like RF, and for decision tree, it's DT. Okay, so if you want to blacklist these models, so there are a lot of models that you need to blacklist. Instead of doing the blacklist, what you'll do, you will just put your selected models in the whitelist. You pick up random forest, you pick up decision tree, you pick up integration, and just go here, and you can just put the select the whitelist is equal to, since this is whitelist is equal to none, I'm going to select this, I'm going to put it here, I'm going to put my models here. So I'm going to put my decision tree model here. I'll just put the code. We need just code here. Yeah, I'll just put inverted commas and I'll put code, and I'll then put RF, and then I'll put LR. Okay, so these are the models I want. So I just whitelist these models, and then the resulting the data frame that I get here is basically of random forest, decision tree, and linear regression. Okay, and in case if you have only some few models which you want to blacklist, then you pick up this Thielson. Let's say you want to pick up don't want this model Thielson regressor, and you don't want Huber regressor, you don't want orthogonal matching pursuit, right? So what you do, you just change this to blacklist. I'll select blacklist here, Okay. And then you mention those models here. Okay, that's it. You just do this thing and you will get all the whitelist models, all the blacklist models, whatever models you want to blacklist, you can do that. If you want some few models, you can whitelist them, right? Folds is something that I wanted to talk to you about. So automatically the model is doing a k-fold cross validation. I guess you guys are pretty much familiar with this technique, right? So it's doing k-fold cross validation, and now it's going to take up your um, the folds as 10. So this is the like the basic folds that we have. Okay, so if you define fold is equal to 10, so this is the default parameter. If you define fold is equal to 5, so it's going to take up 5 folds for your model. Okay, and it's going to do the k-fold cross validation on 5 folds. That is the parameter that you can define. So now here I have ran this model. So I'm going to run this model, compare models, because I'm going to show all the models that we have in our regressive module. Okay, so it's evaluating. So you'll see how fast it does. It just takes sometimes because it's evaluating all the models, right? It's not doing one model, it's evaluating a lot of other models as well. So as soon as the evaluation goes on, the positions change based on the values. So the default value is r square. It's going to optimize based on r square, right? Or if you want to do the sorting based on r square, you can do that as well. Can you explain the folds? Folds is a technique of cross validation, Arijit. If you are you aware of the technique called k-fold cross validation? Uh, I think then you need to go through the concept of. Are you done with ML1 yet? Okay, then probably you should have been covered. Okay, no issues. So it's just a simple concept. Okay, so we are not going to go through that concept because it will take a lot of time. Already we are past our session time, so I'm taking a lot of time here. So just bear with me for a few minutes, right? Yeah, you can do the time series forecasting stuff. Okay, so taking through the fold concept. Okay, okay, no issues. In ML2 definitely you will going to cover maybe there are no models that require k-fold cross validation, so probably in ML2 you will definitely be covered the cross validation part. All right, so let's go forward. So now if you see, so this is the model that I have here, and I'm going to evaluate my metrics. So MA is like mean absolute error, mean squared error. RMS is root mean squared error. R squared is the value that we define for a model. It should be between 0 and 1, right? So if it's close to 1, then the model is good. It's performing well. The model is performing well, right? So that's what we infer. And here I'm looking at the RMSE value. This is like 0.8631, which is like pretty good for my model right now. Okay, so I'm going to go forward, and you can see all the parameters here, the model parameters that we ran, right? So it's going to give me the XGB regressor parameters here because that is the top model that is performing, right? Now, so if in case you want to do the transformation of your variables, or if you want to normalize it, standardize it, if you want to do the transformation of a target variable, right? So that is where you can utilize this functionalities. Again, I'm going to run the setup for here. So the setup will give me this transform underscore target true. Okay, so normalize is something I'm going to normalize all my variables in my data set. So this part is pretty much same from the above line of code. Okay, till this part. Now I'm going to normalize all my variables in my dataset because I don't know whether the model is requiring it or not, because I didn't analyze it as the way we do in our Python, right? So that's why I'm going to run this parameters. I'm going to normalize it. Then I'm going to transform it. I'm doing the transformation, and I'm going to do the transformation of target is equal to true. Okay. Based on this, so whatever operation you have applied, so this is going to give you the result here. So this will be highlighted. Okay. So you have transformed the target variable true, and you did the normalization. You did normalize the data set true, and then you did the transformation also. Okay. So if you want to understand all these functionalities, you can just go to the documentation and you can read based on which kind of parameters it's done, right? So everything is here for you guys. Himani, I think like we don't have much time to discuss those things, right? So what you can do is like you can explore on your own, and if you feel some issues, you can drop an email to academics, right? So right now we are out of time basically. Okay. Uh, yeah. So again, after doing this transformations and everything, I'm again going to compare my model here, and I already ran this code. Again, if you see, after doing this transformation also, my ask query is coming close to 8.8.86, right? So it's 8.86 is like nothing, nothing. There's no difference basically. So this transformation really didn't put much effect on what on a data set. So it's not required as such. Okay. So now if I'm assuming that there are some outliers in data set, okay. So although it says false or something, but still based on, I didn't analyze my variable, right? So the age variable or something. So what I'm going to do is I'm going to put it as true, and then based on that I'm going to do it, and it gives me the remove outliers true operation. Okay, and now I'm going to compare my model again. So if you see, so there's a decrease in the R square. Okay, so I think this step was not necessary. So this is the experimentation that you're trying to do here. So you're going to play with these parameters. You're trying to experiment these parameters, and based on that you will get the results like this. And this results tells that okay, if we remove outliers, then probably our model is going, the performance is going a bit low here, right? Ask queries for linear regression only, right? Yeah. Regression, for regression models, you take up ask query. Yes, right. Okay, great. So let's go forward. Again, I did my operation. I don't want to carry out those operations again. So what I'm going to do, I'm going to again come back to the state. Okay, I'm going to come back to the state, and again, so now, so that line of code I ran because I don't want the remove outliers operations to be carried out. So I'm going to run again this line of code. Okay. So here, now creating the model. Since you evaluated all the models and now you feel that extreme gradient boosting is the model that you require for your modeling purposes, for creating the final model for your business problem. So what you do, you select this model and now you create model for separate model for it, right? So here I'm creating a separate model because you need to, if you want to tune it further, for tuning the model, for doing however parameter tuning and all this stuff. So this thing is pretty much important. So I'm going to take up this variable xgb and then create a model. The create model function will give me all this. So if you want to put an estimator, if you want to create an ensemble method for it, okay, and if you want to change the folds of the fold cross validation, okay, and all these things. So cross validation, if you don't want to do the cross validation again, you can just put it as false here. Okay, so all these things are again utilized here, and if you just create the model based on this, you will get all the folds that you required, right? So essentially the basic default thing is the 10 folds, the 10 fold cross validation that is happening, right? So based on that you will get the average of all the R square values. So the average here is like 8.631. Oh, sorry, 0.8631. That means like 86, which is the R square value, and it's a pretty good model that you have. Now, are you guys clear till this point? Okay, great. So next is, once we're done with our model and we know that my model is pretty much performing well here, okay, still you have some that kind of a thought that like, can we improve it further, right? That is where the tuning of the model comes in. Okay, so again, for tuning, you can see I have this variable tune underscore reg, okay, and tune underscore model, and you have xgb defined here because your model was stored in xgb. Okay, then this function, what it does is it's going to take up again estimator, folds, round, and iterations. This is the important thing here. Okay, so how many iterations do you want to carry out? Okay, if you want to carry out let's say 10 iterations, you can do that because that is a default. If you want to increase the iterations to increase the performance of your model, you can just set it as 50. So n underscore iter is equal to 50. You can then your model will go with 50 iterations. Okay. And if you want to optimize the R square here, so default is R square. So here it's the model is going to optimize the R square. But if in case if you want to optimize something else, so first I'm going to underscore, let's write the code here, and I want to put it as 50. And then I'm going to optimize some other metric. Okay. So that is, I'll take MAE. Okay, I want to optimize this because the default is R square. Here the R square is optimized, but I want to optimize MAE. So it's going to focus completely on MAE, and then based on this parameters and iterations and folds, if you want to increase the folds or something, based on this, it's going to do the calculation and give you the mean results of your tenfold cost validation. Okay. But for the time being, we actually, so to be very honest, we tried the tuning of the model, and we tried this model tuning because this parameters we were getting 0.863 something, and again here it's like 0.8414. You might have a question that it's not improving the model. Why? Because so the reason here is we'd have a very small sample. The sample data is pretty small. If you see and go and look at the shape, so it's like 1338 rows, sorry, rows and 7 columns. Okay, so this is pretty small sample data, and out of this, if you look at the test training data, it's like 936 rows. So we personally think, because we tried the parameter tuning, the tuning of the model on various parameters. Just we took up n iterations is equal to 50. We tried on this. Okay, and we also tried with we increased the folds also, we decreased the folds also, we tried everything, but there was no improvement in the model. I think this is the best model that we can get for this data set. In case if you have good data set, there are a lot of the size of the training data is pretty much high, then probably you can go with much better parameters to tune the model. Okay, so that one thing we leave it out for you to try out on your data sets that you will work on. Okay, so that is the tuning of model that we do. Okay, then now the next is basically predictions, right? After tuning everything, you want to predict the data, right, on test data. So here we actually use this function called predict underscore model. Okay, and then we give the tuned model here, and based on that we assign it to our predictions variable, and here you can see the how the model is performing on test data. Okay, so it's giving us 0.81 as the R square, which is pretty good. I don't think it's a bad model, right? It's not overfitting, and it's doing pretty much well. Don't you think so? What do you guys think about the model performance? Like the training was 8.6 and it's 8.1. Don't you think so? It's performing well. Yeah, right. Okay, great. Right. So that's how you do the prediction, right? Finally, now you come to a point where you need to evaluate your model, right? You already evaluated your model on the metrics that you have, right? Definitely. But again, you need to understand from the plots and charts based on it, and if you want to present it to your stakeholders, that's where you can, this will help you out. Okay, so this is evaluate underscore model, tune underscore reg. Okay, so I'm going to take up this model, which is the tune model, and I'm going to take this function evaluate underscore model. Okay, I'm going to run this. Once I run this, it's simple that, okay, sorry, I need to run this. Oh, sorry. So I'll just start with the XGB part. I'll run tune. Predictions is not necessary. I'll run model. Yeah. In the meantime, let me just take a look at the questions we have. Yeah. Chirac compare models gives us a train scores. Yes, yes, yes. Okay, okay. So I think, guys, this will take some time. So in the meantime, let me just go to the classification problem. It's pretty simple again. It's a bank data set wherein we need to actually understand whether the person is going to get the personal loan or not based on various attributes such as like ID, age, experience, income, zip code, family, and all these things, right? So all this like the basic information that the bank gets from us in various forms. Okay. So again, so this data set is pretty much, I think it worked. Ran. Okay. Uh, okay. Yeah. So let's look at the feature importance of our data set. Okay. Since we are doing XGBoost model. So if you look at, so it created some like dummy variables like or one hot encoding or label encoding that it did. Okay. And some dumbification of the variables, and based on it says like the smoker yes or no is something that are pretty much important. Okay. And the rest of the variables are have a same kind of a importance here. Okay. So this gives us the importance of the picture. Okay. And residual plots will tell you like the error differences that we have. Okay. It will give you the R square values and everything. And hyperparameters are the same things, the hyperparameters that we have in our model. Okay. Yeah. So this is it about the regression data set. So you can evaluate and you can just one more thing I can add here is like you can simply, if you want to just look at one plot, you can use the code plot underscore plot underscore model here. Plot underscore model is equal to, you need to mention, sorry, you need to mention the XGB model. Okay. And you need to mention the model, and after that, okay, I was taking the tune underscore model here. 1 second. Tune underscore reg. So you take this, paste it, and then you just specify the plot that you want. Okay. So residuals is something it takes default, but let's put for feature. I need a feature plot. Okay. So let's run this code. Tune underscore reg. No. I think let's do it for like XGB. Feature importance plot not available for the estimated coefficient attribute. I think it should be available, right? Feature importance, it's features or it's free. Just give me a second, guys. This it's feature. Okay. If we want to go with the residuals, plot underscore model, tune underscore reg. I guess it's taking up the regressor classifier. Okay. Okay, I'll show you here. No issues, guys. I'll show you here. I think I need to run the code again to get to that plot, right? I'll show that code what I was trying to show you there in the classification problem, right? So I discussed about this data set, and it's again the simple thing that you need to do: set up it. Okay, for doing the setup, you need to define the data. So my data is like df1 here, and target is my personal loan. Okay, numeric imputation. If you want to impute it with the numeric variables, we need to impute it with mean. Okay, categorical features, we need to define. So I want to consider these two features as categorical. So see, these are the like things that you can do it in PyCaret. You can define it, and you can then uh, convert it into categorical or numeric based on your wish for the problem statement that you're dealing with, right? So there's mean. You impute with mean, and you convert these variables into categorical, and you want to ignore feature, right? So you ignore these features, and that's how you can carry forward. So you do the setup, the session ID, all these things. So you have 4,000 rows, 14 columns, okay, and then train and test are based on this, okay. All right. So now here, when I do the comparative models, I'm going to blacklist my model, blacklist my catboost model because I don't want it. Okay. After blacklisting, I got the results like this. Okay. So these are the results that are coming out. So if I want to focus on accuracy of the model, I can go with the light gradient boosting machine. Okay. Otherwise, if I want to go with the AUC RUC curve, I can pick up this gradient boosting classifier model. So it's up to you. Decide based on which metric you want to pick up the model. Okay. And now, since I picked up the light gradient boosting machine, so classifier, I'm going to take up this create model option, and I'm going to give this code, which is like the short code for this model. So it's going to give me a 10-fold cross validation score, right? Okay. And now it says like 0.99, the AUC score and the accuracy is like almost 0.98, right? So it's like pretty good model that we have created. And I don't think we need to tune it further because it's almost giving the same results. So yeah, if you want to look at the AUC curve, okay, yeah, probably I need to run the model again to look at the curves. So no issues, guys. So if you want to look at the curves, it's the same thing. You need to click on these tabs. You can just go through the tabs, and you can, if you want to look at the precision recall curve, you can look at it. You need to just press on this thing, confusion matrix. If you want to look at it, you can just put it here. AUC curve, everything here. All you get the happy parameters. Yeah. So this is it. Like this is how you use PyCaret to do your modeling part, the machine learning part in PyCaret, right? So yeah, that is pretty much from my side, guys. So let's focus on some questions here. So basically, I'll open the session for a Q&A. Okay. I know I have taken a lot of time today. The session was basically for 1 hour, but I don't think like I was able to convert or cover it in 1 hour. Okay, thank you so much, Sanjay. Thank you so much, Reena. Right. Shakir, thank you so much. Ryan, thank you. Avinash, thank you. Vikas, thank you. Raja, thank you. Thank you so much. Right. Guys, if you guys have any questions, please post here. So we will answer questions for the next 5-10 minutes, and then we can wrap up for today. My LinkedIn link, like you can just search Insaid Varun Rao. You will definitely get it. Like, yeah, there's only one Varun at Insaid. Just kidding. Thanks, and oh yeah, thank you so much, Rahul. Thank you, Uzma. Thank you, Najmul Haq. Thanks, Abe. Thanks a lot, guys. Thanks, Dr. Manoj. Thanks, Prabhakar. Yeah, guys, please, if you have any questions, please let us know. We will definitely answer your questions, and please try out the package, PyCaret library, and just do the magic. And please be sure that like if you think that you need to explore your EDA and everything or variables in Python, you should be always ready and open to do that, because PyCaret sometimes might not give you the real solution and answer for your problem, right? So be open to both, learn both the tools, learn PyCaret, learn Python as well, and just get going with the machine learning and just become a great data scientist, right? Or else you can, I think there's a new avenue coming up for you guys, like you can actually become a citizen data scientist as well, right? Yeah, you can check if you can use this after EDA, or if you think that you can pretty much cover everything, because I said, right, if you want to ignore variables, if you want to ignore like if you want to convert some variables to numeric or categorical, you can do that. Like you can do the imputation of mean, median, mode, everything here. So like see, if you, the more you go into depth of the features that they're in PyCaret, definitely you will come up with some ideas, some solutions, right? So there are a lot of things in PyCaret. Yeah, you can do that. Sandeep, as of now, PyCaret is the one and only tool that is like has grabbed the market pretty much. I think that is one of the best tools that we have right now to do the AutoML. Yeah, there are a lot of other things like AutoML. You can do AutoML with a lot of other things. S2, there's S2.ai, then there are other things as well. But PyCaret is pretty simple, easy to use. So I talked about my presentation, right? That if you want to just use it for productivity, if you want to use it for like easy, it like business ready solutions, if you want to get business ready solutions, right? And if you want to increase the productivity, and if you want to uh, do it without writing much of the code lines, or if you're a non-coder from non-computer science background, definitely this is a good tool for you, right? No, that's not the case, I guess, Rajiv. See, as I said, like new avenues will come up, right? So now you can become a citizen data scientist, but the seasoned data scientists are already there in the market, and they won't be going anywhere because we have need of them, right? We need them to build models, build algorithms, right? Work on large data sets, deep learning, computer vision, right? So PyCaret is still in the nascent stage where you can actually just do few things and come up with solutions pretty fast, right? But if you have a real problem, like let's say you want to do the image classification and stuff, right? Then probably you need seasoned data scientists who can work on it and you can come up with solutions, right? Possibly you can think that it as a new avenue that came up to the market, and now you can explore it. You need to just get the expertise of PyCaret, and then you can just jump into the market and become a citizen data scientist. Yeah, thank you so much, Rajiv. That's great. That's great. You need to just create model, right? You just Harsharan, Harsharan, you just need to create the model, and then selecting model is something you can do with blacklist or whitelist. If you want to select the model, and then you can just blacklist the other models, and you can, whatever model you need, just select it and then create model, and then you can just evaluate based on it, right? All right, guys. I think we have spent a lot of time today, but I think it was pretty useful, and you guys have learned a lot of things that will help you in future in grabbing wonderful roles in the market, and obviously it adds to your toolkit as well, right? Thank you so much for joining, and I have taken a lot of your time tonight, so sorry for that. Anyway, like have your dinner and have a good night. Yeah, thank you so much. Bye. Bye. Thanks a lot. Bye.